In this lesson, we're going to be looking at area formulas. We're going to do a few videos on area formulas. For this one, we want to understand what the area formula for a rectangle is, understand what the area formula for a parallelogram is. Some important vocabulary: area, base, and height. Now, we're going to start with a rectangle. So I haven't marked it as a right angle to prove that this is a rectangle, but we're going to say that it is just because I'm going to do a little bit more drawing on this. Some of you may already know what the rectangle formula is, but I want to explain why it is what it is. So here I've labeled the height as 3 and the base as 4. Now it doesn't matter if we're measuring in inches, centimeters, meters, any of those. The idea is that any measurement, as long as we're consistent with the measurement, will be usable. The idea here is area is measured in little squares. So we're looking for squares that can fill in this rectangle. So what I can do is I can use the number for the height and the base to tell me how many sections to divide it into. So this base is a 4. So I'm going to divide it into 4 equal sections. So I know that these won't be perfect, but we're going to kind of say that these are all perfectly even. Okay, we're going to say that all of these are the exact same width here, same length. Okay, and this 3 is going to say that we want to divide this into 3 equal spots on the left, and then I'm going to draw those out. Now these may not be perfect, but let's just assume that they are. Okay, based off of these measurements, if we say that these are perfect squares, I know they aren't, but we're just going to say that they are for now. If we say that these are perfect squares, what we can do is we want to count how many squares there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, the area is 12, so we want to look at how we can use 4 and 3 to make 12. Well, it comes from 4 times 3. Or base, which was what the 4 represented, times height. So the area of any any rectangle can easily be found by going the base times the height. We use a lowercase b and a lowercase h, whereas area is represented by an uppercase A. Okay, now we want to look at a parallelogram. Now, a parallelogram has this look to it. I'm not going to draw the squares on there because I believe that I've already proven the formula for a rectangle, and because of the angle that these lines go at, that doesn't work very well. What I want to show you is that with a parallelogram, we have this little triangle created when we measure the height from this point here. So what we can do is we can actually take this triangle. So if I had a scissors, I could cut that triangle off and place it over here. So I'm going to do that with my red pen. So basically what I've done here is I have gotten rid of that triangle, and if you notice, what shape has been created? Well, the shape, by taking this triangle and putting it over here, has become a rectangle, and we already know the formula for a rectangle. So a parallelogram has the exact same formula as a rectangle. It's the base times the height. The key here is the height has to be perpendicular to the base. With a rectangle, the height is automatically perpendicular because of the right angles in a rectangle. But a parallelogram does not necessarily have to have right angles, so the height must be shown as perpendicular for it to actually be used. Alright, if there are any questions or things that you missed, make sure you pause, rewind, and rewatch, and bring the questions that you can't answer yourself to class. Thank you.